we have to prove cos A plus B plus cos A minus B is identical to 2 cos A cos B. So let's take the left hand side and write down the question. Cos A plus B plus cos A minus B, and if we break it down, it's going to be cos A plus B is going to be cos A cos B minus, because if there is a plus we have to write minus, sin A sin B. So this is going to be one thing, plus, and cos A minus B is going to be cos A cos B. Since there is a minus we have to give a plus, plus sin A sin B. So if we add it up, this thing minus sin A sin B and plus sin A sin B cancels, and it is going to be 2 cos A cos B. So therefore the left hand side has been proved to be equal to the right hand side. So if you take a look here, P is the position of A plus B and Q is the position of A minus B. So we can have an equation and say A minus B is equals to Q. So this is equation 2. Now if we add the two equations, if we add equation 1 and 2, what we get, A plus A is twice A, minus B plus B cancels off, and we get P plus Q, and from there we get A equals to P plus Q by 2. So we find a value of A, and similarly by putting this value we can find the value of B. We know B equals to P minus, if we send the A to the other side, P minus A, and the value of A is P plus Q by 2. The bracket is very important because this is a unity whole thing. So if you take the LCM as 2, P into 2 is 2P minus 2 into 2 is 2 ones are 2, so bracket is P plus Q. So if we remove the bracket, this is going to be 2P minus P is going to be P, minus into plus Q is going to be minus Q. So we are going to get P minus Q divided by 2. So now we have the value of A and the value of B. So if we move on, we can write, we know that cos A plus B, which we proved in A, we know cos A plus B plus cos A minus B, let me remove it, is identical to 2 cos A cos B. Therefore cos, in A plus B we can write P because we have said A plus B is P, plus cos A minus B we can write Q. It's equals to 2 cos A. Now the value of A that we found was P plus Q by 2. This is the value of A, and the value of B we found was P minus Q by 2. So this is going to be, this is cos P plus Q by 2 cos P minus Q by 2, and therefore proved left hand side equals to right hand side. The previous sum was cos P plus cos Q can be written as 2 cos P plus Q by 2 cos P minus Q by 2. That means if we have a cos and an angle plus cos and another angle, we can write it, this is some sort of a new formula, a sort of a new formula for cos. This is a new formula for cos, we can consider it. So we see that this thing can be considered as cos P and this thing considered as cos Q. So we can think of this as P and think of this as Q. Why not this one? Because there is a 2 here. For that formula to work, it should be free. So using that, we can write cos P plus cos Q is 2 cos P plus Q by 2. P plus Q by 2, 8x plus 4x by 2. So 8x plus 4x by 2, and cos P minus Q by 2, which is 8x minus 4x by 2. We can write it, and we have cos 6x, this is left, so plus 2 cos 6x is left. Okay, so now we can write cos 8x plus 4x is 12x by 2 is 6x, so 2 cos 6x, and cos 8x minus 4x is 4x, 4x by 2 is 2x, cos 2x plus we have 2 cos 2x plus 2 cos 6x. Now we can take 2 cos 6x to be common. We can take 2 cos 6x to be common, and we get cos 2x plus 1. Why that thing was given? So we can write 2 cos 6x. So instead of cos 2x we can write 2 cos square x minus 1, and we have this plus 1 from previous line. So in the final line we have 2 cos 6x. This 2 and this 2 becomes 4 cos 6x, and this one and this one cancels, so we get cos square x. So we had to prove 4 cos 6x cos square x, and this has also been proven.